Good afternoon. Welcome back to Science Shorts with Mr. Perkins. I'm Mr. Perkins. I'm a science teacher who is running for state senate and is choosing to use this time during quarantine to try to produce some short videos for everybody so that hopefully we can all learn a little something and it's at least something to break up the monotony of quarantine. But it's only a week and a half left until things are done. We will have videos this Friday and then next week as well. So please, if you have additional science questions that you would like answered before then, send them in and I'll make certain in these last couple videos we get to them. But today, we are finishing up that egg experiment. You remember last time, last Friday, we took a raw egg, put it in a vinegar bath, and found out that that vinegar, over about 48 to 72 hours, will decalcify the shell around it. And then we can do some neat osmosis tricks to pull water out of the egg by soaking the egg in syrup. And then, what I asked you about last time was try to make a prediction. To be a good scientist is to constantly be making predictions. And we're going to talk a little bit more about that at the end of today's video. But we had the egg in syrup, which shrunk down a little bit. The syrup outside of the egg was going to pull water through the membrane via osmosis so that that water could try to balance the particulate percentages inside and outside the egg. And then we were going to stick an egg in distilled water. And again, distilled water is just H2O. There's no salt, there's no sugar, there's no minerals, there's no nothing. It's just water. I wanted you to predict, what would that do? If the egg in syrup was going to pull water out of the egg, what was the egg in distilled water going to do? So we're going to take a look at that today. And then, like I said, we're also going to talk a little bit about that prediction process. Because people kind of get that wrong a lot of the time, both in science and in general. And I want to talk a little bit about that. But let's get to our eggs. Let's center the camera on the egg. So we've got our raw egg. And then we have our egg that was in syrup. And then, so last chance to get those predictions in, our egg that was sat in distilled water. So there you can see the size of the raw egg versus the size of the egg that's stuck in distilled water. And you can see how squishy this is. And then I'll hold up these two as well. So you can see, there we go, that and that. But you can see how much bigger this one that was in distilled water is. And hopefully you had the time and the ability to do this in person so you can see these and hold these because it's cool to squish this egg. And again, it's fun how truthfully durable this is. Like, don't get me wrong, you can break this without too much difficulty, but you know, we tend to think that the shell of the egg gives it all of its strength, and it gives it a lot of strength, but this is still surprisingly durable. But again, you will be able to break it. So let's talk a couple things here. So this egg, and this is, well, let's start with this one. So this egg got bigger. Stuck this in distilled water, and as osmosis tries to balance things out, the water is going to enter this egg because there is particulate matter inside the egg. When we stuck it in distilled water, there's no particulates at all in here. So to balance that out, water is going to enter the egg as much as it can in order to try to balance out these two percentages. And that's going to cause the egg to inflate. I did have somebody in my household ask a question: if we leave this in distilled water long enough, will this burst? I've never tried to leave it in water for longer than about 72 hours, leave it in distilled water for 72 hours, but the strength of this membrane, the physics of this membrane holding tight will eventually overwhelm the forces of osmosis. So I don't think it will burst. I've never seen an egg getting so big in distilled water that it would burst. I mean, this is still a little squishy. It's not like it's super taut, but that was a fun question. So the water has entered the egg here and made this larger. Water has left the egg here and made it softer. And again, this is all because of this semi-permeable membrane that surrounds the egg that we get to play with now that we removed the shell off of it. So I'm going to set our distilled water egg aside, and then I want to talk about this and the process of predicting, because I've done this experiment a bunch of times. I've done it in the classroom for my biology students. And then I've done it with some homeschool groups that I've been a part of. And this is actually one of the less impressive results. Like if you Google naked egg, you will find that and look up others that have been soaked in syrup. They get wrinkly and leathery and really shrink down. And it's taught me something a little bit about the brand of syrup that I get. That I think this brand of syrup is more watery than past brands that I've gotten. But so I made a prediction that if I put this in syrup, this was going to shrink down. And it did a little bit, but truthfully, it didn't the way that I predicted it would. And you may have made a prediction about our distilled water egg and what was going to happen with this. And you might have been right or wrong with that. But, pull back up here. So, science is about predictions. It really is. We learn that scientific method in school at an early age, but we don't really come back to it as often as we should. You make a prediction, you test, you compare your results against the prediction. And too often, people phrase an experiment or a prediction as successful or not successful based upon whether the prediction was correct. I predicted this egg would shrink down. It didn't as much as I thought it would. Therefore, I'm wrong. Therefore, I'm a bad scientist. That is not how science works. That's a very bad train of thought. Science works if you learned something. Putting things in a prediction and then testing against that is a really easy way to do it. But we need to remember that the result we're looking for is whether or not we learned. And I did. I learned something about the brand of syrup. That's not what I set out to learn, but that doesn't change the fact that I learned it. And it certainly doesn't make me a bad scientist because my prediction was slightly off. If you predicted something else would happen with this egg, like that it would burst from the water or that nothing would happen or any number of other predictions you might have had, and you were wrong, that doesn't make you a bad scientist as long as you now understand, oh, look, this is how osmosis works. There are many examples throughout the history of science of people getting, lab towel, always important science, of people getting predictions wrong, and us thinking back on them as great scientists. There's the famous Edison quote of somebody asking him, you failed to make a light bulb, you're a bad inventor, and him saying, it's not that I failed to make a light bulb, I discovered 1,000 ways not to make a light bulb. And there's truth to that. He learned. When we also think about other concepts like the discovery of the structure of the atom, the idea that the atom has a nucleus and then electrons go around it, that was also accidental. I'm not going to tell the full story, but effectively it was a prank. Somebody asked a new person in the lab to record data for something that they thought there'd be no data for, and the guy went and he recorded the data and he came back and he's like, all right, here's the data I got, and that data was the basis for us learning the structure of the atom. So they made predictions and they were wrong, but they learned something and they used that new knowledge. And too often in our discussions of science, and I'm running for state senate, so too often in our discussion of politics, we judge right and wrong in not helpful ways. Right and wrong, if you are doing good science, you've made observations, you've gotten new data, and then you've taken that and you've learned something. You've changed your mind to better fit the data that you've gathered. That's good science. Whether or not your hypothesis was correct, whether or not your prediction was correct, good science was whether or not you learned something and you obeyed the scientific method, you looked at your data, you made your conclusion fit the data rather than forcing the data to fit your conclusion. So I'm going to harp on that, making predictions as long as I have students, making predictions, testing against that, and if your prediction is wrong, but you still learned something, you did good science. If your prediction is wrong, but you learned something, you did good science. It's always important to have that did you learn something as the basis for science, not whether or not your prediction was correct. So, that's kind of my finale for this. I hope you enjoyed it. This naked egg experiment is one that I've done, and it's the right amount of gross and weird, but also really cool that good science can be. And so I hope it caused you to think a little bit. I hope you enjoyed it. It's an easy one to do at home. Again, just take a raw egg, soak it in vinegar for about 48 to 72 hours. Sometimes you have to rub the rest of the shell off. And then if you soak it in something like syrup, it's going to shrink down. And who knows, maybe your results were better than mine and that this really kind of shrunk down for you. And then if you soak it in distilled water, it's going to balloon up. But again, you know, take a flashlight to this so you can see through it. It's neat, it's safe. And then again, make predictions, look at your data, and then use those observations to learn something. And if you're learning something, you're doing good science, whether or not your prediction was correct. So thank you very much. We're going to be back on Friday. We're going to be doing probably some more online stuff on Friday. And then next week, like I said, Monday, Wednesday, Friday, we're going to be doing additional videos. Since currently it looks like that'll be the end of the stay-at-home order. That'll be the last of the videos that we record. But if you have additional science questions, send them in, and I'm still happy to answer them. Thank you very much. This has been Science Shorts with Mr. Perkins doing the naked egg experiment and learning a little bit about osmosis and the way science works. Have a good day.